All right, so I talked about depth first search, which used a stack. Hopefully you figure out where this is going. Well, let's change this up a bit. And let's put this back here. We can do those. But this time we want to use what is called a breadth first search, where we basically want to record what the next moves are, try them, record all the next possible moves, try them, record all the possible next moves, try them, record all the possible next moves, try them, record all the next possible moves, try them, so forth and so on until we get to where we need to go. So in this version, this example, breadth first is not going to be too helpful, but let's go and take a look. So we start at 0, 0. We were there, so we'll go ahead and mark it. And then we're going to keep track of where we can go. Well, where can we go? We can go to 0, 1, and we can go to 1, 0, right? That's where we can go. All right, well, let's go try 0, 1. So we're at 0, 1. We're not at the end. We mark it. We decide where can we go. Where can we go? Well, we can go to 0, 2. So let's add that to our list. All right, and then we're going to go to the next element in our list, which was back at 0, 1. Let's mark that, and we add where we can go. Where can we go? We can go to 2, 0. Right? Okay. Then we go back to our list, find out what's in front. So it's over here. We'll mark it. We add all the places that we can go. Where can we go?
0, 3, and 1, 2.
1, 2. So we add that. Then we go back to the front of our list, 2, 0. So we're going to mark that. We add everything we can go, where we can go to. Where is that? What's that one? 3, 0. Right down here. We can't go over here because there's a wall. But we can go down here. Okay. Then we go back to our list. We're at 0, 3. So we're right here. We add everywhere we can go, which is
0, 4.
4. Then we're going to go to 1, 2, which was next on our list. Where can we go? 2, 2. Next on our list was 3, 0, so we'll mark that. Where can we go? 4, 0. What data structure is this? Loud and proud.
Q.
A queue. So depth first uses a stack. Breadth first uses a queue. Et cetera, et cetera. You notice how it's kind of like branching all the way out, trying each one of them until it gets to the end. So breadth first, you're limiting it by how many steps you've taken because you're restricting the order by the steps taken. Depth first, you just go all out one way and then come back. Okay. Let's code this up. Hopefully you all saw that coming. Good morning. Army, welcome back. Okay, so we have our depth first, and that was good. So let's copy our depth first test, and we're going to be so happy we wrote all that, because now we can just do our breadth first test. Put it over there, and let's take this guy. Hey, look, we'll change it to a B. Did we put this in our HPP file? There. There's our breadth first one. Let's go back to our CPP. There's breadth first search. Tab new to test, comma BFS. Breadth first search, that's what that stands for. And then find everywhere that says depth first and go to breadth first. And hey, look, we have test cases. Wasn't that great? Now we don't have to write all of them because they're already written for us. Oh, that's great. It's amazing. It's like all that extra work we did earlier just paid off. And I just realized this was called test 4.
So that's literally the only difference between the two terms of code?
Right, because they perform the same, I'm sorry. They are used to get the same result. Therefore, the interface is the same. The function call is the same. But they're going to do them completely different. Well, not completely. They're going to do them very differently. And that's why this worked out so well. So let's make BFS, warning no return statement, non-void, and we failed miserably. Perfect. That's exactly what we wanted. So now we're ready to make our test cases pass. Okay. So, time for a breadth first search. Now, in the depth first search, we used a stack, but we used recursion because recursion is the implicit stack of the machine. So we're not going to do this one recursively. We need to use a queue. We've talked about a queue, so let's go ahead and actually create a queue for us. And I can never remember the interface because it's C++, so let's go over here and let's do C++. And I'm just going to look up list because I thought that was the easiest way to do it. All right, list of, okay, good. So we need to make a list. We need to make it a list of something, so I'll do that, and we'll call it to visit.
Does C++ have their own queue?
They do. We could use that,
Okay.
but I'm going to stress that we're implementing a queue with a linked list in this regard. And also, I don't want anyone to be tempted to use a queue for the queue exercise when you're not allowed to at this point. But good question, good question. Also, the actual queue may use something else. All right, but what is it a list of? Well, oh, I erased it. But what was I making a list of? Coordinates. There's different ways to do this. You can use the STL pair class, but let's just create a class. You called them coordinates. How about points? We'll just call it point class. And we're going to make our lives really easy. There. It has an X and a Y. And we'll make this even easier, and we'll have a constructor. Let me make these semicolons so it's a little simpler. And there we go. So it's going to be a list of all these points. Let's make sure the compiler is not going to yell at me for anything. Oh, it is. It was not declared in the scope. That's because this list has std. Expected semicolon after class def. You are correct, C++. That is what you require. And no return statement. Okay, so let's go and return false. All right. And now we should pass one test case because we guessed correctly. Good. Okay, we're still wrong. So the point to visit, and that's going to be our list of points to visit. When we begin this, I'm going to help you all out to get this started, to make this easy. When we start, and in a breadth first search, you are actually giving the start position. We're going to do to visit dot, what was it? Push back, bless you, point, our start position and start Y. That way it's set up correctly. Now let's make sure that it accepts that syntax that I just used. Great. So, in other words, we're at this point where our list contains 0, 0. By the way, pay attention because your lab is an extension of this, of what we're about ready to do. Spoiler alert. All right, so we need to set this up. One way to set this up is to determine when do we know we have failed. Well, if there's no more points to visit, then we have failed, right? So let's go ahead and create the simple while loop. While to visit dot, is there like an isEmpty function or something along those lines? I hit the backspace too soon. Empty. All right. So while to visit empty aka it's not empty. We'll have point P equals to visit dot. And so we pushed in the back, and if it's a Q, we're going to pop from the front. All right? And then at this point, we're going to work with the point. Non-scalar type point requested, conversion from, okay. And what does pop front do? Oh, because that's not what we needed. We need, that's delete the first element, but we need front. I got my Java and my C++ all mixed up. There we go. So you get the front, and then you delete the front. Remember, in C++, those are two separate operations. Perfect. Set but not used. Let's run it correctly this time. Good. So we still failed. All right. So get the next point in line, Q. And now we're going to work with the point. What do we need to do? No, it was. Gotta be part of the conversation, right? What do we do? Holland? We throw the points around? I just did.
Well, do it.
You don't do it? Questions of answering?
Just give up.
Just give up.
Give up, go back to sleep.
Well, we're over here. We get the point, which is right here. What's the first thing we did?
We'll check to see if the next thing is.
We checked to see if we can go right. Right, that was one thing we did. So let's write that down. When algorithms are complex, it's great to write them in English. So check if we can go.
This is not English.
Check if we can go right. It's an English sentence.
No, I mean the rest of this.
Right, that's why we write comments, so that it's in English and we can figure it out. Check if we can go right. What else should we check?
Well, if you have to check if you can go right, you gotta check if you can go the other directions.
All right, so let's go. Actually, this one should have been, well, I think we were doing
Right,
down,
we
left,
left it up.
and up.
I think in that order.
That's fine. All right. Anything else we should do?
Let's see.
Sorry.
Check if the point has been visited or is a wall.
Oh, okay. Should we check? We should do that before we can go right or left, right?
Yeah.
I think we got it.
If point is visited or a wall. All right. Anything else?
It's out of bounds.
Out of bounds. All right. We should probably do that first. Well, yeah, we should. We'll do. Yeah, we'll check. We should probably do that first. Yeah. Okay. Good old check 0. All right. Well, let's go.
Are we sure if we want to check if visited and wall at the same time? Because there are different things that happen.
Well, if we're visited or we are a wall, then in our case we just need to continue the loop. So first we'll check if we're out of bounds. So if p dot x, you know what? We already wrote this, right? And it's not return false, it's actually continue. Do y'all remember that keyword? So in other words, jump back to the beginning of the while loop. So you're in your while loop, continue the while loop. Don't do anything more. Just go back to the beginning of that loop. All right, so we're in bounds. And now we're what? Check if the point is visited or a wall. So let's see. Here we go. Okay, great. Now what do we do? Check if we can go right. All right, how do we check that? Or we could just add everything to the queue since we're checking afterwards when we pop the point to see if we're allowed to go there, right? So we could just add it to the queue. So it's really add left, or I should say right, down, left, up. So then you go list dot, and it was push back, point, sub s, sx, sy. This is not correct. Because I'm going to make at least y'all write this part. All right, go ahead. Y'all do this. Not me. You do it. Okay. We add little points. All right. Ready to try it?
What is continue do again?
It jumps back to the beginning of the loop. So if this happens, then it goes back to the beginning of the loop, check to see if the queue is empty, grab the next point. So ignore the rest of it, is what it's saying. Don't execute any more of this loop, just go back to the top of it.
Okay. So do we need something at the bottom of the loop that like changes the point?
Maybe. Hold on. What was our error? Was not declared. Oh. Hey, look at that. I must also be tired. To visit. There we go.
It's just one of those days.
Just one of those days. Bum 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 bum. Brr, 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 brr.
Yeah,
Hmm.
it's not hard.
Huh.
You're having problems.
This is where the autograder says either nothing or timeout. What's going on?
Quite honestly.
You've got this. What does this mean?
Wait, what?
You don't have to tell me what's wrong with the code. You just tell me what is the program doing?
You've done stuff in the loop.
It's stuck in a loop. Well, it's great that we have one loop, because then we know which loop that is, right? So it's stuck in the while loop. Oh, killed. Ooh, it was killed. Nice. It got too big, okay. So why are we stuck in a loop? Well, if you don't really know, it's always good to start printing things out.
Well, that's not good.
No, that ain't good. So it's 0, 1, 1, 0, 0, 1, negative 1, negative 1, 0, 0, 1. Wait a minute.
Wait a
Minute. It's just doing circles. Why is it doing circles?
Probably told it to.
That's correct. We did tell it to. How did we tell it to go into a circle? We did this in depth first search, but forgot to do it in breadth.
No solution was found. Sorry.
I'll put my cursor over the line that should give you a big hint.
Oh, we didn't mark anything.
Oh, we didn't mark it. Don't mark the point. All right, now we've marked the point. Oh, so now we just fail. Great.
Cool.
Cool. Nice. Oh, wow, we just go in a loop. Huh. Hey, so what are we doing wrong now? Well, we got rid of the infinite loop, so now we fail. So that's progress. Progress.
Would it be something with the SX and X, SY, for like the pushback?
Let's see. Well, you know, I just realized we never actually checked to see if we were at EX, but that's probably the first problem we should.
We don't need to check that.
All right, fine. If air, px equals ex, and I should do p dot x. Whoops. P dot y equals ey. Then we found it, right? All right. We'll see if that fixes anything. I don't think it does. No, we're still 25%. We're stuck in some weird loop. So 0, 0, 0, 1, 1, 0. Wow. Look at all that. Oh, I know. Oh. Let's see. Hold on a second. I think C++ is betraying us. Did I do pushback? Just pushback. Please tell me you're not doing it by reference. Oh, it's by reference. Oh. Of course it is. Oh, C++. Why are you like this? No, that's not what I meant to do. There we are. Okay, we're going to do this instead because I don't want it to be too annoying because it's going to get really annoying. I just realized I'm just doing it and not telling you the problem. Oh, I didn't do a thing. That's not the problem. That's weird. Really? That's not the problem.
What is this problem or not the
Huh.
problem?
So the problem is it's taking a reference, which means it's pointing to what's on the stack and not copying it over. Wow, that's weird. But why is it doing this? Ooh, this is weird. Why is it going in a loop? Now I actually don't know. Ooh. So we make a new point. Correct. So that. To visit. We make it the P equal the dereference of that. Well, let's go ahead and just make it a pure pointer. And just there we go. That's not what I want you to do. Ooh, am I gonna go on the fill? This might be that'd be terrible. Let's find out. Yeah. Okay. Almost there. Nope, it didn't like that at all. Oh, that's funny. All right, why are we going in a loop? Because what I suspected was happening is that since point was initialized on the stack and it was keeping a reference to it, it was actually keeping the reference to what was previously on the stack and just reusing the same memory values over and over again. But that luckily is not what it's doing behind the scenes. Instead, our code is just wrong. Which is, in a way, good. Oh, you know what? It is staring us in the face. Y'all ready for this?
Yeah.
So ignore every. Oh my
Whoa.
goodness. Whoa.
Does not like that.
It did not like that at all. Let's see if we can. Problem with Tmux is I haven't figured out how to go up yet, and I need to figure that. Point requested. Oh, because I still have a pointer right there. All right, so I took that. Now let's go do it. I really hope it's making copies of the reference and not. Okay, there we are. Wow. Well, that was fun. Oh, look, we passed. It's a tough love. Let me get rid of some of these test cases. And which one was the was it 3? Yeah, it was 3 that was the interesting one last time. So let's comment out 4. Okay, we'll put the print statements back in. I hope test 3, nope. Oh, because you can't comment them out. Oh. Instead, you have to delete them. Otherwise, the unit test. Okay, let's try that again. The unit tester will not do it. All right. So, yeah, test 3. Which, if I recall correctly, was this situation. Am I on the board? Not at all. Oh, good. We're going to finish just in time. What's this situation? What did depth first search do?
All the way around the way.
It went all the way around. What did breadth first search do?
Branch.
Notice that's test 3 right here. I mean, it tried these two, but that doesn't really count. It tried this, then it tried that. Found it, done. Right? So, breadth first found it really fast, as opposed to depth first search. By the way, just go ahead.
Even though we set the bounds to 0 up to grid 4, why did he check the negative?
So that's a good question, and I was about ready to go and let me put this test case back in. Usually, when you do a breadth first search, what you should do here is that if px was it p dot y plus 1 is what's it going to be less than h, then add the point, because you only want to add the point if you can actually go to it. And so this would be p dot x plus 1 is less than, and then down, this is easier because you just do if p dot y minus 1 is greater than or equal to 0. And then p dot x minus 1 is greater than or equal to 0. And this makes a whole lot more sense because you don't want to go to something you can't go to. Another time, you may also want to check if there's already a wall or something there. And usually this is where you put your checks in. But we'll just do this check because it's a simple optimization. Yeah, now if you look at this, whoops, and my mouse pointer's gone. All those negative ones are gone. And it rechecked going back to itself, which you should also check if you're trying to go to a mark spot. And the nice thing about doing those checks is now you don't have to do this, right? So this is, we don't have to check 0 because we implicitly make sure we're within bounds down here. Let's go ahead and run our tests to make sure we're still correct. All right, so there's some confidence that removing those checks is okay. And then other ones, next you would put these two guys basically down in these if statements. So then you wouldn't have to check those again. You would check them just to make sure you only visit a spot that you actually need to visit, which is a good idea. And then that cuts down even more on how many points you have to visit. Because the more points you visit, the longer breadth first search takes. So you want to visit as many as possible, or visit as few as possible. So that's why you put the check before you have the point. Great question. Any others? All right, how are we doing? So C++ is a little annoying sometimes, but that's just how it is.